A very good evening to one and all present here. I, Nasir Hussain, welcome you all to this webinar organized by the Alumni Cell of Kamla Nehru Institute of Technology, Sultanpur. It's an absolute pleasure to have you all here for this very special occasion. Today, we are here to embark on an enlightening journey, one that will inspire and inform us about the incredible possibilities in the world of technology, which will connect our bright minds with a seasoned professional. On that note, let me welcome our esteemed alumnus, today's speaker of the webinar from the USA, respected Mr. Alok Kumar Singh, sir, 2012 batch, Computer Science and Engineering Department, currently serving as Senior Software Development Engineer in Amazon. He is not just an alumnus, he is a beacon of inspiration and an embodiment of achievement. His journey from our institution to the heart of the technology world is nothing short of remarkable. It's a testament to the boundless opportunities that the tech industry can offer. Today, he is here to share his story, the challenges he faced, the lessons he learned, and the insights he gained on his path to success. His experiences and knowledge are invaluable to all of us, and we are fortunate to have him as our guide today. So, without any further delay, let's get ready to be inspired by the tremendous journey and let's buckle up for an evening filled with insights, motivation, and invaluable knowledge. Sir, you may start.
Hey everyone, hi. I'm Alok. I think you already got like a brief introduction about me, and hey, thanks Nasir about providing those details. Yeah. So I'll start with like a bit more details about myself. So I graduated from KNIT 2012, and then I joined Wipro as my first company as software engineer. Worked there for around 1 year, and after that I moved to Deloitte. Worked there for 1.5 year, and then I joined Amazon in Hyderabad. Worked there for 1.5 year, and then moved to Seattle, USA, and like from 2017, I'm working here at like Amazon. Mostly work in different like organizations, especially finance, advertising, and currently working on AWS. Yeah, so we'll let me share my screen and then we'll discuss things what we want to talk. Yeah. Hey, can you guys hear me?
Yes, sir, you are audible.
Sure. Yeah. So yeah, we can start. So yeah. So I think I already gave my introduction like about my career and where I started. So we'll cover like about like we'll discuss about what all topics we want to cover, what are today's agenda. So a couple of things which I want to cover is software engineer career track, like different options based on my experience, where people usually go and what is specific skill set required for them. And then we'll talk about cloud computing, and then some of the major software careers which I have extensively worked on. We'll talk about them, especially like backend software engineer, and then machine learning engineering, and then big data. And then we'll have like I think I'll try to have sufficient amount of time so that we can discuss. If anyone have any questions, if anyone want to talk about things, we can cover that. Yeah. So let's move on to today's agenda. So first thing which I want to talk about is software engineer career track, and you guys may heard about it from maybe some of your colleagues or seniors or maybe friends. Hey, there are different career options. You can move to this track, or you can join as this role in an IT company. So I want to talk about some of the major career paths where like which is a bit popular in the industry, and then we'll discuss some of them is like what skill set required going into those career options. So first one, which is I think all of you may heard about it, like software development engineer or software engineer. So when we go out of college, most of the companies provide this role like software engineer, like hey, you will be joining as software engineer. So this is pretty generic role. Lot of time when we start our career, with experience, we move to more like focused roles, or sometime we even still stay as software development engineer. So software development engineer is pretty wide role where you're expected to work on different set of application development, software development. Um, it's not focused on any specific area, so that's why a lot of companies provide this role. Even they have senior level role, you can have like software, like level 1, level 2, senior, principal engineer roles. So this is pretty popular role, and this is more back-end software engineer role, you can say, software development engineer, where you are expected to develop different softwares. Basic knowledge is at least you should know us programming language, data structures, and lot of computer science fundamentals. And that's why it's a bit diverse role. There are a lot of opportunities in this role, but same time there is pretty steep learning curve in this role, because every time a new thing is there in market, you are supposed to learn that as a software developer. You are going to maybe implement that in the organization you are working on. So this role is more generic role, and mostly it's recommended for people who are pretty interested on like backend software development, um, and they are pretty eager to learn, especially later phase of your career when like you need to learn new things or develop new things. A lot of optimization need to be done. So that's more like software development engineer role. Then full stack engineer, and this is also pretty popular, especially in service industries. So full stack engineer and software development engineer is bit similar. The only difference is like here, lot more focus is on application development. Like you may be building a web application, and you are supposed to know front end side of it, more focus sometime on front end, and then back end side of it also, but not like extensively back end engineer, where you may be building back end services which support front end websites. So it's kind of a jack of all role, and this role is pretty popular in early phase of career. But when usually people get experience, so with experience it's like you are supposed to increase your depth in a specific area, or where you are kind of like hey, you are most knowledgeable person or you are pretty knowledgeable person. So that's where full stack engineer is more like jack of all. You're working on web, you're working on backend, you're supposed to know. So kind of DevOps role. And then front end engineer again, this is more focused role. So now from here onwards, we'll move to more focused role. Usually people move to these roles when they want to stick to one specific vertical, and they want to increase their depth. And especially if you want to be uh, as an individual contributor. So when I say individual contributor, it's like hey, you want to work as a software engineer, don't want to move to leadership role like manager, director, and all those. So then front end engineer, you will be focusing more on web development. You're supposed to understand like a lot of web development related components, more focused programming language, which is like more web focused, like let's say JavaScript, TypeScript, CSS, and all those front end specific components. Yeah. So people who have like interest in web development, this is a pretty good role. Front end engineer. Um, lot of time it along with programming knowledge, you need to have bit of, you can say, um, like color understanding, or bit of you can say creativity when you go to front end engineer. It's like how you are going to design your websites, what font you should choose, what color coding you should choose, a lot of things start mattering. Like when you get experience, you need to design those things. And the next role, which is started becoming popular in like last 4 to 5 years, is data engineer, big data engineer. And then we'll talk about it in detail later. But this is more data focused role, and like a lot of you may heard about it, like machine learning, artificial intelligence, or business decision making. Everywhere we use data, and with internet available kind of everyone, there like huge volume of data generated every single second, and we need to process them, generate them, and produce a meaningful information out of that data, so that we can use it for different purposes, like maybe training ML model, or making another business decision. And that's why with data volume increase a lot in last 5 6 years, this role became pretty popular. And this role where people want to move, it's more like you can say you like learning about business, you like how any data or any information makes sense, you want to deep dive that. That's where like more um, focus comes on this role. So it's still a software engineer role, but more data focused. You may be working on a technology which is data focused, like maybe you need to be pretty good with SQL, pretty good with Python. A lot of people in data space use Python as programming language. Yeah. And then we'll move to data scientist. So data scientist is kind of a role where you are supposed to work with ML and data. So data scientist is more a bridge role between an ML engineer or applied scientist. Some organization call ML engineer as applied scientist also, um, and data engineer. So it's like you can say ML. So we'll maybe first cover ML engineer, then we'll move to data scientist. So ML engineer, or some companies use terms like applied scientist, and in some places domain specific people go like economist, or research engineer also. You're supposed to understand software engineer related stuff. May not be that much depth, but at least you know how to code, you know to how to process data, how to deploy your stuff. So along with that, you need to have more research skill set on like machine learning, especially like again it comes back to data, how you infer meaningful information from data, how you decide what information I use for training my ML model, so that we can use it for business purposes. And that's where this role mostly goes. Like a lot of people you see in this role is either having PhD or maybe lot of interest in research. So most of the time when you want to move to ML engineer role, if you want to go into hardcore research or hardcore ML development, it's recommended like you have PhD, or you need to get like a lot of research citations during your career, if you want to grow in that role. And then data scientist, again a bridge role between data engineer and ML engineer. So data scientist is someone who is supposed to understand a lot more business in compared to data engineer, and then should understand basics of data engineering, like how to process data, how to transform it, how to clean the data. So it's more like a bridge role between a research person and a software engineer. And then system engineer is more focused on, you can say, application support and some of the DevOps part, like let's say networking. Lot of organization system engineers manage networking, infrastructure, monitoring, alarms. So system engineer role is more from operations perspective. It's pretty important, but it's not heavy development focused. And now like these are roles mostly like each companies have. And when usually we go out of college, a lot of time we go to software development engineer, but that's where we need to figure out where our strength is and what role we want to choose. And I'll talk about some of them in detail. But what I'll suggest is like, let's say if someone is going out of college, you try to figure out where your strength is. Like maybe you are really good with software engineering fundamentals, data structures, object-oriented programming. In that case, software development engineer role is pretty good. It's pretty diverse. There are so many opportunities. But again, with diversity, it comes like, hey, you need to know a lot of things. You need to keep learning new things. Whenever you want to grow in your career, you need to increase your depth a lot. Along with you need to increase your breadth a lot. Like any new thing coming in, you're supposed to know that. Or like when you become a senior engineer or principal engineer, your organization expect you like, hey, this new thing in market, can we use it? Like, hey, there is a lot of hype about language models. Can we use it for our use case? So you are supposed to go and do that research and do a lot of that stuff. So this role is where there is a lot of growth, but there is like you need to put so much effort. Other roles are more like subject matter focused, so you need to put lot of effort, but with the time you develop that subject matter expertise, so learning curve is not that steep. Like in any of other roles, if you go like front end, data, ML, or system engineering, if you are able to understand those fundamentals to start with, then with time your learning curve is not that steep. So it like it depend on like, hey, where do you want to go, also where your interest is. Like let's say if someone has lot of interest in web development, then full stack or front end engineer role make lot more sense versus other roles. Or if someone have like lot of interest in data, then data related roles like data engineer, data scientist, or ML engineer make like lot more sense if you have research oriented interest. And we will talk about it in detail, like lot of ML related stuff, which is like there's so much hype, but it's like how it varies when you move to that role, what your day to day work look like. It looks fancy, but what do you need to do on day-to-day basis? So we'll talk about them. Yeah, let's move to next stuff which we want to talk is like cloud computing. So there's like so much hype about cloud computing also in the market. And I personally work with Azure and AWS. Azure I worked for like around 2 years, and then AWS I'm using it on my day-to-day basis from last 7 8 years. And I'll talk about because there are so many people is confused like, hey, what cloud should I learn? Should I just focus on learning about cloud computing? Um, will it going to help in my career and all those things? So like let's start with like what is cloud computing, and some of you or most of you may already know it. Is like it's mostly um, like hosted services where it's mostly using web services interface where they provide you can say infrastructure or platform as a service. So mostly when like in college, when a lot of you do development, you use your own laptop, you install operating system in your laptop, you install database, you install servers, like maybe you are using Tomcat, Apache Tomcat or something, and then you do all the development on your local machine, and then maybe you host that website somewhere. But when we think about an organization, especially growing organization where like scale is infinite, that's where on-premises infrastructure, which is like your own servers, your own hardware, become bit complicated. Like if you take an example of any new organization, like let's say um, like Flipkart or PhonePe or any company, is like when you start that company, you don't know how many users you will have tomorrow. And in this internet world, you can get popular maybe with just some like hype or some ads or things like that. Maybe today you have just 100 users, tomorrow you start having like a million user who's using your app or your website. Now when you start developing, you don't know how many users you are going to serve. So if you just buy like 10 servers, you just spend so much money, all the money you had, and to develop your application, deploy it, and let people use it. Maybe if you just buy two servers, then if tomorrow you get popular and from next day there are 10 million people start your application, it goes down, and then all those users are gone. You just lost your company. So that's where cloud computing become like comes in the picture, where like hey, someone else is renting the infrastructure or renting entire services to you where you can use those services. So basic fundamentals and concepts are still same. What you do on your own laptop or a big server or a cloud computing infrastructure, if it's exactly same. So a lot of time when you try to learn it, like hey, I want to learn about a cloud like AWS, Azure, Google Cloud or something, you need to start from your own laptop. Hey, I'm doing this on my laptop like this. How I'm going to implement this thing on a cloud provider? Like if you take an example, like hey, you are using MySQL database. So if you want to install on your laptop, you need a laptop operating system, and then you need that software license. You need to upgrade that license when new version comes, and then you need to create like database tables to access that data. But and especially if you go in industry environment, it become more complicated because there are security patches in operating system, security patches in database. So you need to keep upgrading your applications, your databases. Now a lot of these things are pretty complicated. Companies has dedicated teams for all these things. That's where system engineering comes in the picture. They manage a lot of these things. But when you go with the cloud, they provide different kind of services. Like you can just rent a machine which have like some CPU, RAM, networking power. You can install your stuff if you are good with installation, managing your hardware. Let's say if you just want to develop an application, you don't want to worry about all these things. These cloud providers just provide entire database as a service. So you can like they provide APIs. Let's say we want to use MySQL, they provide. You can just provision like say I need a MySQL with this much CPU, this much memory, and then you go ahead connect it using username, password, create your tables, databases. Now you don't need to worry about like what server is used behind the scene. If you want more CPU, more memory, you can go ahead and request tomorrow. They will upgrade within like minutes or within hours, and your application will start running for more users. Or even a lot of these are coming as a platform as a service, or even software as a service. Like you don't even need to worry about like what database to use. You can just say like, hey, I need a database um, which support these kind of interfaces, and they provide you APIs. If you want to create table, you call this API, provide your create table syntax. I'll take care of creation of table, insertion of data, you file select statement, I'll give it to you. So it's like now all the infrastructure cost is like taken care by someone else. You need to pay that cost, but you don't need to worry about a lot of that skill set which you need to manage. And that's where when you start uh, maybe your career in organization, a small organization, a startup, you see like most of the people are software engineer, maybe using some cloud, developing their application. They may not want to learn so much stuff about like networking or backend and all those things. Um, but sometime when you move to big organization, the cost for this cloud may be a bit expensive. So they're like, hey, I want to use some of the cloud stuff for things which is not predictable, like let's say Diwali sales. So you need lot of infrastructure for that. So like, hey, I can rent machines from them, but for predictable workload, I don't want cloud. I want my own machines because it's cheaper. So that's where cloud computing comes in the picture. It's like you are offloading all the management of infrastructure part to someone else. You just need to worry about your own application, your own business. Like let's say if you're building a startup for something like a e-commerce site, You just need to worry about like, hey, what your website have, how your supply chain will work, what all content you want to show on your website, how you want to set your price. You don't need to worry about how many machines, how much CPU, how I'm going to purchase it. Am I going to get some discount when I'm purchasing these servers? So it's just like, hey, and then you can scale your application. So that's the benefit of cloud. And then and that's where we try to where to use cloud. Different cloud providers. There are so many cloud providers. I think more than hundreds. But most popular one is like AWS, Microsoft Azure, Google Cloud. And then each cloud provider have different services. And when we talk about like different services, you can relate it back again with your laptop when you are developing your application. Like if you are developing an application, mostly or a web application, let's say you need a website, you need a storage, and then you need a compute. In your case, or if anyone who is developing a website on their own laptop, everything is laptop. Like RAM is there. Laptop is a compute machine, you can say, which have RAM, CPU, and then hard disk is the storage. But when you go into cloud, all these things is managed by different services. Like storage, they provide like different type of databases because different workload varies. Like let's say if you want relational database, there is a service for that. There are different services for different type of relational database like Oracle, MySQL, and then there are like other data storage solutions. Like let's say when you have big data, you may want to use MPP databases like Redshift, Snowflake, or you want to use file system like S3, which is like directly storing your data as files. It's a lot more cheaper. It does not need that much hardware. Or you may want to have cold storage where you want to move your history data. You may not want to remove that because of audit or government regulations. Like like banks, they need to have last 10 years of data. They cannot remove your transactions, but you are not going to access that information. So if they are storing that on a like costly hard disk, it's going to cost them a lot of money. Like, hey, I want to move this on a like cold storage. And traditionally, how it used to work, at least one of the organization I worked with, they used to do is like they used to copy this data from server hard disk to a like cheaper um, hard disk and then manually move it to their different data center. And if you need that data, they need to go and bring that hard like those cheaper hard disk from data center, connect back to the server, copy the data back again. But on cloud, most of these services provided, you can access everything over the internet using APIs. And with like optical fiber and high internet connectivity, you don't need to worry about like they provide like tens of gigabyte bandwidth you can use that or hundreds of gigabyte bandwidth you can use that for your application. So that's where like the different cloud services, like let's say for databases, for storage, if you want to get servers, there are services for that. There are services for managing workflows. Like let's say if you're managing a website which accepts order, but it need to process those things in steps. Like hey, accept order, ship the order, collect the payment, and then mark it success. So you need to have a workflow. So they have a workflow service where you can mark like, hey, I want these 10 tasks run into serial or parallel. Or there are services for notification. Like let's say when you have an application, you want to, when someone place an order, you want to send a notification that your order is placed. So the services like notification services where you can send your message and provide like whom do you want to send, it will send a notification to them. Um, so like there are like for different things there are different services. When you are developing all those things on your own machine or server, you need to install everything, you need to manage everything, and that's where cloud comes in the picture. Like they will manage it for you, they'll charge a fees, but then you don't need to worry about a scale. You don't need to worry about like, hey, what happens if new version comes? Because one thing which is pretty common in software engineering world, is every year you need, like, there is a new version, or there is something which is not backward compatible, you need to go and upgrade your application. And that's where a lot of time it's called like, if you're building anything which is you think is like it's going to take more than 2 year or 3 year, just stop that, because in 2 3 years technology will be entirely changed. So if you're going to take 2 3 year to build something, it's just that it become obsolete. And that's where cloud became pretty popular, is like, hey, you don't need to worry about managing this infrastructure which can take you months, you just focus on your application. Yep. And then you can read about like law, all different services where it's used on internet. When you want to understand that, I'll say just focus. How will you do same thing on your laptop if you don't have anything? And then you can easily manage that. Like, you can easily relate it back and learn those things, because fundamentals are same. And then we talk about like backend software engineering or software development engineer role, which most of the companies have, where it focus. So mostly backend development focus on, like, so when you see mostly a website or anything, that's the front end part. When you submit anything, like let's say if you go to google.com and search something, behind the scene it need to do like hundreds of things. Like let's say when you put a search request, google.com shows you ad, so it need to figure out based on your like keyword what ad it should show you, uh, because based on like let's say what keyword you have, if they will show you proper ad, you click on the ad, you purchase those product, they will earn money. So they need to figure out what ad to show, and they need to search like entire their indexes where like, hey, what all pages I should show to this guy based on his keyword or his or her keyword. And then they also need to make sure is like which sites are more popular, because when you go and search on Google, you see like, hey, top 5 6 results you get, which is non promotional websites, is usually based on how popular they are. So they maintain need to maintain those indexes also, like how popular some websites. So that's also need to manage behind the scene. But from a user perspective, we just see like, hey, I went and searched on google.com. It showed me some content, some advertised, some non-advertised. But behind the scene, all these things may be managed by tens, hundreds, or thousands of systems. And building those like applications or services or APIs like require pretty extensive knowledge of some programming language, data structure, and all those things. So that's where backend development come in picture. Is like building those backend services which can scale uh, for thousands, millions, or even billions of requests. Especially if you see like um, promotional sales, sometime like let's say Diwali, or big billion day or those things. Within like minutes, there will be like hundreds of million or a billion requests for something. When the people try to search something on a website, now their search functionality supposed to support 1 billion requests within that minute or that second. So they need to figure out how much servers I need to support this, how to make sure when a request come, which server it goes, because there may be 1,000 server, but you need to load balance them, because if one server is taking all the request, it will go down. So which request to send where and all those things. So like then that's where, like when earlier I was talking about software development engineer, it's pretty diverse field, where you need to do everything, you need to have knowledge about everything. And that's where like when we in college, lot of subjects which we study, we think like, hey, it's of no use, especially most of the time we give to data structure or learning a programming language. Sometimes people learn about databases and all those things, but mostly we don't give that focus on networking, file management, memory management, operating systems, all these things. But these become pretty important when you work on a high scale system. Like, let's say if you are working on a backend system, which is supposed to have like hundreds of servers or thousands of servers and serving requests from users. Now you need to make sure how they interact with each other. So you need to make sure, hey, there are thousand servers, but they should be within a network so that no one can connect to them from outside world and no one can get your data. So that's where like networking, security, and things comes, and how you are going to store your data. That's where a lot of that knowledge comes in the picture. Is like, hey, you studied about memory management, file management, or a lot of those in like algorithms which you we mostly study in college, like binary tree, B tree, B plus tree, and all those things. When you work on a high scale extensive system, you'll see getting implemented in real time. Uh, so that's where like backend development comes in the picture. And this is one more microservices and monolithic architecture I wanted to talk, because there's so many times it's talked about, and like there are a lot of confusion around that, like where to use what. So usually monolithic architecture is something, let's say if you are developing, let's say a website, or maybe if you take the example of a e-commerce site. So you are developing an e-commerce site on your laptop. You created one big application. You implemented all the functionality there. Like, let's say one component is for taking the order, one component is for shipping the product, one component for third party, like from the store going to pick it, or one component maybe if you are going to buy and resell it, and then one component is for delivery confirmation. So there are five, six components are there. You build everything as one application. Now what happens? It's like pretty easy to build because you don't need to think about what data to send from one place to other place, because it's everything is one application. You can easily send data from here to there. There is no networking involved. You don't need to worry about sending data over the network because everything deployed at one place in maybe one machine or one server. So it's pretty fast. Um, and it's faster to develop. But when you think about a scale, how you are going to scale these things, now what happens if you need everything is built as one big application? If you want to add a new functionality in your like e-commerce search part, like, hey, I want to introduce an ML model which is going to like track customer behavior, and based on that show the search result. So when customer comes and search like, hey, I want a laptop, so you can only like on a page you can only show like 5, 10, or 20 laptops, but there are like thousands of laptops. So you want to show like the best laptops based on that customer behavior, or the data you have. You don't want to show like any random laptop, because then the chances of customer buying that is pretty less. But if you are showing something which is customer is already interested in, then the chances customer will buy is a lot. So now you want to introduce this new functionality, but you need to test everything. You need to test like order part, shipment part, everything, because all as one application. Maybe adding a new feature in search will break your entire application. So your development process will become slower when you grow. And that's where microservices come in the picture. Is like you build each component or each small service, small thing as a service. They interact with each other over the network. So like let's say there is a search service, which is when someone comes on front end, someone search something, front end will call the search service like, hey, this is the keyword, give me the results. Search service will give the result, front end will show that. Then someone try to go and click on one product, then there may be another service which is product management service. So when the customer click on a specific product, it will send that product name or ID to product management service and tell them like, hey, send all the details about this product to me, and then they will show on the web page. And then if someone place order, it will call order service. Now if you see, there is a central service which interact with each other, does not do any work, so chances of failure are pretty less. All these independent services work on themselves. So if someday your purchase order or ordering service have issues, you don't need to worry about everything else. Everything else will be keep working fine. When you resolve your issues with ordering service, that will also start working fine. So it will not bring down entire system. So that's where microservices comes in the picture when you think about like a scale. In some cases, monolithic makes sense. Like let's say if you are building a new startup, you don't want to from day one you don't want to think like, hey, I need to build this 100 services for my this startup, because then you the thing I was talking like, hey, you don't want to take like 3 years to build your application because then it become obsolete. That problem may be solved by someone else. So you may want to start with a monolithic service, and as and when it grows, you can keep breaking it down in different services. So and then yeah, there are a couple of other things like a lot of time people have questions. Hey, what programming language should I learn? And even personally, I had that question when I was in college. Should I learn Java, C, Python, or what should I learn? Over the time, I understood that hey, you don't need to learn a lot of programming language. Just pick one programming language, any one. It does not matter. You don't need to know. And most of companies, like at least tech companies, does not give any preference to any specific programming language. They're just like, hey, you tell the programming language in interviews, and then whatever programming language you choose, like maybe you may not want to go back and choose something like in COBOL or something, but like anything which is bit popular, choose any programming language and you solve the interview question in that programming language. No one cares like, hey, you solve this in Java or you solve this in Python or C. So mostly like you pick any one programming language, learn it in depth, because when you move programming language to other programming language, 90% of things is exactly same. Syntax may change, your data structures will still be same. In Java it may call hash map, in or map, in Python it may call dictionary, but your concept fundamentals are exactly same. You spend a month or two and you can just learn a new programming language. It's that simple. So like a lot of time in college we get diverted where, hey, I want to learn some C, some Java, because in interview people can ask anything. Just like that will not help in long term. Like just pick one programming language, learn it. Yeah. And then when we want to go on like backend software engineering, what topics to focus? I think we already talked. Most of them is like pick one programming language, learn about data structures, learn about software engineering or software fundamentals. Like, hey, when I store a file in a hard disk, how it gets stored. When I run an application, like let's say you are running a browser on your laptop or a VLC player or something, and you play a really big movie or open a really big file, why it starts slowing down? Like it may be using more RAM. So why it's that RAM is important when you save the same file in the disk, how it's saved. So those fundamentals is very important when you go into backend software engineering, and you need to deal with all those on day-to-day basis, like memory management, especially you are working on high scalable system where like you're dealing with billions or trillions of data sets every single day. If you write one bad component and then your memory footprint increase a lot, that your infrastructure may fail. Okay. And then last point is like who should choose this as a career. So I'll say backend software engineering someone who want to go in depth in software engineering. For those people, it's pretty good. This has lot of growth opportunities. The only thing is you need to learn a lot. You need to read lot of books. You need to read lot of code, and you keep learning. So it's not like hey, you learn something and then hey, you became pretty good with that, and then you can stop there. Even after 10 year, 15 year, 20 year, you have to keep learning things. And that learning curve is more and more steep when you go into backend versus other things. And then next thing, I think we'll talk about like machine learning engineering. So there's a lot of like talk about like hey, I want to work in ML and all those things. So um, I worked with them like in ML for like 3 years, mostly when I was working with advertising. So like I want to talk about like hey, when someone says like I want to develop a machine learning model or ML model, what does that mean? Where ML is useful, or who should focus on that? Like from outside perspective, if you open Chat GPT, or if you open any other which is using ML, it seems bit fancy, but what goes behind the scene, and for what people it make a lot more sense. So usually when we start with any ML model development, and a lot of you may read already about it in books or somewhere, mostly it's like it's supervised and unsupervised learning. So like you use history data to predict the behavior in future, like what happens if this happens. Like simple example is when you use your credit cards, and if your credit card mostly you spend maybe 1,000 rupees maximum most of the time, suddenly you go and do a shopping of like maybe 2 lakh, and then your credit card transaction may get declined, and then you need to call and say hey, I was the one who was making this transaction, and they approve it, and then transaction succeeds because they flagged it as there is a fraud detected, and they tracked your behavior, or a lot of customer behavior is like hey, this customer was using mostly like doing all the transactions of less than 1,000 rupees, and then suddenly why 2 lakh rupees transaction happened, there is something wrong. Or sometimes it's like if you live in a city or a country, you keep using your cards or your net banking and everything, suddenly you try to make a purchase on an international website and your transaction get declined. It's like hey, like this does not lies within your region or based on different factors. But if you keep doing that international transaction 3 4 times, then it picks up and says like hey, there's like no failure. So ML is mostly useful where you are like trying to predict something or trying to infer something based on past information or based on the behavior, um, like your model learned. So when you start developing any ML model, uh, I'll say 90% of the work is bit pretty boring with ML model development. The 10% of work is interesting, but 90 or 95% of the work is really boring. um, it's interesting work, but it's very boring. Like when we talk about life cycle of ML development, you figure out a problem, you want to solve it, then you start looking into data. And when I say start looking into data, it's not like you just go and look some data. It's like hey, you need to look into billions trillions of transaction behavior, just like you can say sleep over it, understand that data. Like if you have, some of you have read that Chat GPT, I think GPT-4 use more than 175 billion parameters. So that's just parameters. Number of records it's using maybe in like more than millions of trillion, mostly entire Reddit, entire Stack Overflow, and all those things. used to develop that language model. So it's like someone need to spend lot of that time to analyzing that information. Based on that, like, hey, deciding what type of model to use. There are different models and you can read about it for different use cases. For financial use cases, different models. For like behavioral use cases, different model. So that's the most difficult part, and that's where a lot of research mindset comes in the picture. And we were talking about that role, ML engineer or applied scientist, and data scientist, and data engineer. So that's where ML engineer or applied scientist or research scientist, and if we go in finance world, mostly economists comes in the picture. They do a lot of this work, or sometimes like software engineers also get involved and do a lot of that work. Is like doing research with that data, to figure out like, hey, what information to use, like what parameter to use to train my model so that it does not produce wrong result. So that's, you can say, 50% of that work is figuring out what information to use, and then what model to use. And then once you figure out that, done with 50% of that work, you build an algorithm. Is like, hey, I'll pass these information, I'll use this model get trained on this data, and then I'll use it in real life. And that's where the data scientist role comes in the picture, because you know kind of the steps and things like that. So you need someone who understand ML space a bit, and who understand bit of software engineering or data, and can do that work, like maybe develop a code or something which can pass this information and train your model. Um, and then now training this model, you need this data, like petabyte or zettabyte of data to train your model. Maybe aggregate lot of that data, produce in different, clean that data. That's where, and maybe bring that information. Like, let's say, Chat GPT use lot of Reddit information, lot of Stack Overflow information. So you need to call their APIs to crawl that data, or you need to crawl the entire internet. So that's where a lot of data engineering comes in the picture. How to bring that data, clean that data, store that data properly in a format so that it can be used um, for different use cases. So that's where those three roles usually um, used, and data engineering is used outside ML also, but that's where a lot of these three roles come with each other to develop a model. So you figure out, you analyze the data, you figure out your model. A lot of that work is mostly happening in Excel, or sometime in your local machine, looking into things, sometime even high power machine, just to process that data. But again, you're just processing that data or running some SQL. Um, then once your model finalized, you train your model, you keep testing your model, like, hey, you train on a billion records, and then you pass next 1 million and see if it's able to produce correct result or not. So that's where, after training this model, you move into production. And there are so many use cases of ML. And that's where, when we are working on a problem, we need to figure out, hey, where is, if ML is best fitted use cases. Like, let's say if you go back and say to a bank that, hey, you use ML to generate my bank statement. You don't use like a standard software. Then it's like, if you are using a model which does prediction, there is chances of like failure or like wrong result. That's where, when we deal with ML, we track accuracy, how accurate that model is. And you may have read a lot of places like, hey, sometime for things like Chat GPT or other things provide wrong result. So now if they provide you wrong bank statement, you like will get mad. So then they cannot use ML here. But at the same time, if a transaction is fraud or not, they can use it, because if they flag something which is not fraud as fraud, then it's like, you can go back to them and ask like, hey, this is not a fraud, I am doing this transaction. Or You can say a lot of in advertising, search world, and there are so many other places where you can use ML model. Like the use case I was talking about, like, hey, if someone is searching which top pages to show, it's not just based on maybe popularity, because if you are searching something and based on your behavior you may want India specific search pages. So your behavior, your location, and all these data points considered, and then it try to get data from India specific pages. Or you may be interested in something else based on your behavior, like based on your age comes in the picture, it may show that. So that's where a lot of places ML is to be used. And then where to focus if you want to go into this role, it's mostly you need to have research mindset. You should like to live with data, understand business is like you are very curious, hey, why it's happening like this, what happens if I will do this in place of this. Um, and you like looking into numbers, um, and see like, hey, how will it look if I do this that. So that's where mostly research mindset, lot of patience is key for success. The software engineering knowledge comes in the picture, but most important factor is research mindset, focus, patience, because it's possible that you'd work on 10 models in last 3 years. Out of 10, only one produce more meaningful result, nine just fail. Yeah. And then who should choose this as a career? As I mentioned, like you need to have more research mindset. If you are interested in data, like it's possible that you are as an ML engineer and entire year you may not write any code. It's very much possible. You're just dealing with data. So that's where this role comes in the picture. It's pretty interesting role. It's pretty popular in the market, but it's not for everyone, because if you like doing like fast paced software development, then ML may not work for you. Like you may involve into this and you may not get interested, or you may try to do things very fast without focused understanding, and then your model start producing wrong result. So that's machine learning engineer. And then the last thing we want to talk about is big data. And this is also very popular, especially with lot of IoT devices, heavy internet users. Everyone, every single app, every single company produce so much data, and they want to analyze that data to acquire more customers, get more business, at the end earn more money. So like you can like there's so much in like big data users you can see around yourself. Like Google, even when you go to any website, you see in the bottom there is a Google plugin which usually website embeds on their web like page. So whenever you visit any website, Google gets that data you visited this website. Sometime even they get data like, hey, on which page or on which frame of website you stayed how much time, or even Facebook, Instagram, which reel you watched, what type of reel you watched, or which video you looked for long, or which page, which post you watched for how much time. So all this information is tracked back in behind the scene. Now, if you think about like Instagram, Facebook, Amazon, or all these use cases, is like every single second there is billions of records get collected, or all this like terabyte of information every single gets collected, stored somewhere, mostly in file systems, because a lot of this databases does not support. So you need to process that data, produce meaningful information, so that business can make decision on them using that data. Now, if you think of this scale, like hey, every single second you are producing a terabyte of data, and you want to run a ML model for last 5 year of data, you can think how big it is going to be. Like you may end up processing a zettabyte of data, and then You may not even have like there is no machine which can store this much data in memory. Like there is no machine which have this much RAM. So then you need to think about distributed processing. Can I distribute this data across like 10,000 of machine and process parallelly? Because you want to process it faster also. Um, and then you need to figure out, because this is so much information, how can I aggregate it or cluster it so that someone can easily make this decision using this data. Um, an example is like, let's say, if you are having a ML model which need to be trained on all this information, they may not care about customer ID level information. They may care about only specific attributes like gender, location, and all those things. So you can aggregate that information, and this trillions of record can become just a billion record, and then your model can successfully scale. So the big data is more about collecting this high volume of data, processing this high volume of data, and making it available. And lot of time, one thing which comes is like, a lot of time when we talk about data, people relate it with databases and SQL. And that's where it's like, hey, it's not interesting. But with in current world, the amount of data we process is more like we process like hundreds of terabyte data every day, which cannot be done in like smaller machines or just using SQL or very basic fundamentals. You need to use a lot of distributed computing. You need to optimize it a lot, and that's where I think if you read about it, there are a lot of processing engines, some of them open source, some of them supported by some companies. Is like, hey, like a Spark, you may heard MapReduce and all those things. And then a lot of people in big data world use Python heavily. Scala also used pretty heavily. Some people use Java also. So when we talk about like big data or data engineering, it's more like a software engineer with expertise in data, not a data analyst who like just keep playing with data. You need to build software for processing this high volume of data. And then what all areas to focus in big data? It's you need to be kind of good with again understanding business, because when you're processing data, you need to understand business to know meaningful information. It may not be same as someone who is a business analyst or someone who is an ML engineer, because you don't need to go into that deep, but still you need to understand business. So you need to have interest into understanding business. It's not just writing code. And then like a lot of distributed processing, especially heavy networking, like because you have this huge volume of data, you process them using thousands of server parallelly. How they get how data move across different servers, how to optimize that, those things comes in the picture. So and then SQL is very important, because a lot of time you make this information available for end users. uh, they don't write code, they sometimes they write SQL, sometimes they just see visual reports. So then you should have knowledge of that space also, so that you can support them. And then who should choose this as a career? I'll say, if you like to play with data, if you like scale, um, and yeah, you like to be challenged about like, hey, like core software engineering fundamentals, um, like especially like with high volume of data when you want to process over the network, it became really complicated. So like this, like if you want to get into that debug, like you may process like a billion record, and then out of that one failed. So you need to debug that why it failed. Maybe someone passed date in wrong format or whatever it is. So that's where like you need to have that like understanding of data, how it works, business, and all those things. This role is also becoming pretty popular, in especially last 4 or 5 years. So this is more like software engineer with data focus. So you usually, if you are working on this role, you will not be asked like to build a random software. But if you go into backend engineering, you mostly can be asked to build any random software. Yeah. So that's about big data, and I think now we will move to Q&A. If have like any questions about things we talk or anything else, or anything you guys want to discuss, I'll turn off the screen sharing for now. Yeah. Yep. Um, anyone want to take the questions, and then we can go ahead with them. Hey, I think whoever is the admin can unmute the people who raise hand, and then we can take the questions. If that makes sense. Hey, Um, do we want to unmute the people if they want to ask questions? Or if there are no questions, I think, I have provided this PPT and my LinkedIn. If you guys want to reach out, feel free to message if you have any question. Yeah.
Now everyone asks the questions.
From where I can start the coding journey. We are mostly in the first year, and we are not getting a clear vision from where we have to start a direction, sir.
Yeah, I think that's a good question. I'll say like when you want to start it, maybe there are like a lot of websites which provide like step by step courses, or even YouTube. You can get like so many people provide like videos step by step. I'll say like pick one programming language which you think like, hey, makes sense for you. And if you ask me, someone who is just starting, maybe Python is the easiest one you can start. Or a lot of time in college we study C. You can start with that, um, and like start understanding data structures. Yeah, and writing basic code. And once you are to a level where you can write the code, basic code, I'll say go to GitHub, read a lot of code written by other people. Yeah, like 90% of your learning comes when you read others' code. Yeah. Hey, your voice is pretty low. So,
कोई बोल रहा है हटा उसे उसका खुल जाएगा माइक्रोफोन Good evening, sir.
yeah.
Sir, I have a question that you have told us many aspects and many domains related to our technology.
like big data, cloud computing, and machine learning, everything. I want to ask that, sir, what's the common language? Means which is the language which is used most in, which is the most wide case used language, and it is most popular and used in most of the languages that sorry, the domains that we come across, that you have already told, sir.
So I'll like mostly we use Java, Python, and C++. Most of the places you see like these three languages or a flavor of them is used. Like Scala or Kotlin is kind of similar as Java. So these three languages or a flavor of them is used. And I'll say like if someone want to start, Python is easiest to start because there are so much libraries, easily um, accessible libraries which you can use. You don't need to write a lot of code to do simple stuff. So I'll say like maybe someone who is like not focused on a specific area, you just want to start somewhere. I'll say start with Python, understand data structures, and Python is mostly used everywhere. And then if you understand Python and data structure, tomorrow if you want to move to Java or C++, there is a minor learning curve, but you can easily learn that. And especially a lot of people prefer Python for coding interviews because you need to write like less number of lines of code. It's faster to write, so it's pretty good for interview. Yeah, and Python is pretty extensively used in anything related to data, like data engineering, data science, ML space. It's used pretty widely. Java is mostly used building like high scale services. But again, if you know Python, it's pretty easy to learn Java. It's not that difficult.
And sir, what about the JavaScript, which is means it is widely used like in front end, back end, and
Yes.
even it is used for logic.
Yes. So yeah, learning JavaScript also good if you want to focus on front end. Like hey, if you're interested in more into front end development, yeah, then yeah, it makes sense to learn JavaScript. But if you have to choose, like let's say if you ask me like hey, if I have to choose just one language, I'll say choose one between Python or Java. Um, because of wider support. JavaScript is good. You can learn that. You can clear interviews with that also. But most of the time, when you like are like into Python or Java, you understand like bit of backend space well. It's easy to move to JavaScript and front end space versus moving from front end space to backend space is bit difficult. Yeah. So if you're interested in front end, yeah, JavaScript is kind of must. Yeah.
Thank you, sir.
Welcome. Yeah.
So myself Ashit Pandey from mechanical engineering first year. So I want to know that how to if someone want to switch from core branches to IT sector, what should we do?
So based on my experience, I'll tell you some of the best engineers I worked in last like 10 years. A lot of them were like uh, before coming into software engineering, they were in nursing, medic, chemist, or something like that. So it's not that difficult because at least I have seen some examples and they are like really good engineers. Um, so I think you whoever want to do that is like start with one programming language, start writing code. Once you like start writing code, just basic code. Sometimes even just go and get someone else code and just read it and try to understand why this person wrote like this. And sometimes what happens, you put your problem into, like, let's say if you are in mechanical or civil or something, and you try to write or build something related to your problem. Like, let's say if you are in mechanical, maybe like, hey, what about if you want to build a business or something which take care of maybe providing information about like cars, engines, or whatever it is. So now you can visualize the business side of it, or like presentation side of it. Like, hey, you want to build a website that will show these three things, these 10 things. So now you are pretty clear what content you need, and then you can write code and map your content and maybe start with building a website or something. So I'll say it does not matter branch, because most of the time, even if you see people in computer science or IT, um, I think 90% does not focus, or maybe does not go that deep into basics of fundamental like computer science. Most of the people focus on learning a programming language, and once they learn it, once they have a use case, they go back and read those fundamentals of computer science. Like, at least for me, like when I start working on some problem, there is a networking challenge, I go back a lot of time and read about like networking layer, how TCP work, how UDP work, how packets of data get sent, what happens when a packet is lost. So you don't need to, like, if you're from core branch, you don't need to worry about like, hey, someone is from computer science studying all these subjects like maybe networking, compiler, or whatever. You start with a programming language, start writing code, basic code. Lot of those subjects and things comes in the picture when you start working on high scale application. But then now you understand the code, you understand basic data structure, you can go and read them, you can relate them. So yeah, it's pretty easy, at least. Like, start writing code is pretty easy, it's same. And if I'm not wrong, I think everyone have C as a subject in first year or something. Yeah.
Thank you, sir, for your suggestions.
So should I go for my master's degree abroad or from India? Should it add value if I go abroad for my master's degree?
So it yeah, so one thing which I like to add in is like um so especially depend on universities. Lot of universities in US, um and I think some of them in Canada or Europe also, they have more like research focused culture. So when you go for a masters or any education, college comes in the picture mostly when you want to build that relationship, or when you want to work into a cohesive manner where, hey, you have same like-minded people, you can discuss your problem with them and then solve some problem. um, so I'll say, like, yeah, if you want to go for higher studies, you can do it from like outside India, but don't just do it because you want to do it outside India. Like, if you are getting a really good college in India, that is far better than going for a pretty bad college in outside India. But if you are getting a decent college, like, there's nothing wrong. You can go outside India. Um, you need to figure out your finances. Sometime you can, like, get job, you can manage your expenses and other stuff. But if you are getting a good college or a decent college, I'll say, yeah, go for it. It depends on what college you are getting. Yeah.
Thank you, sir, for your answer.
Thank you, sir.
Yeah. Okay, yeah. If we don't have any more questions, then we can, I think, uh, uh, stop the meeting, and like feel free to reach out to me if you have more questions. Yeah.
Yes, sir.
Good evening, sir.
Hello.
Good evening, sir.
Yeah, good evening. Yeah.
This is Yash Giri from Computer Science Engineering. Sir, I have a question that being in first year, what should my first priority? Like, I should go for GATE or I should focus on coding. So just tell your point of view as of being in first year.
So I think what I'll say, like if same thing someone would have asked me like 10 years back when I was in college, or maybe 7 8 years back, is like, hey, go for gate. Um, but now, because of like internet, or like lot of like non-college focused um, like jobs, like lot of companies does not focus on like just college, and it's pretty easy if you have knowledge, then it's pretty easy to move from one company to another company, and like you can move from any company to any company. Yeah, it does not matter where you are working on, or a lot of time you can even clear it from college if you are good with that. So if you ask me, being in first year, I'll say, especially in computer science, um, start focusing more on like coding, and like maybe same time you, um, let's say, study your own subjects, give like time to them also, um, and maybe down the line after 2 years, maybe when you are in third year or something, if you feel like, hey, you are good, that where like you are confident that, hey, you can clear like any company interview, or you have good understanding of computer science, then I'll say like, hey, it makes sense to go for a job, versus if you are going for masters just for a job, then it makes sense to go for a job. But if you feel like, hey, um, I don't have that good understanding of computer science, I need more time to study, or I need exposure for a college which can provide me exposure to a lot of other companies, then it makes sense to go for gate. So maybe I'll say evaluate in at midpoint, um, and as of now maybe start like doing a lot of coding, focus on your subjects, yeah, because just going for masters, because if you are not interested into research, or if you just going for job, if you feel like, hey, you can do that without going there, it because it does not add like so much uh, value from job perspective. uh, Mostly you go for any specific topic or subject, you study for 2 years, but it's not like it's going to add so much value if you are not interested in research. Yeah.
All right, thank you, sir.
Good evening, sir. Sir, I want to know that how to explore ourselves in optimum time. In which field we are best, like web development, data science, AIML, and cloud computing, etc.
So I think, like I'll tell what I do, is like you need to start somewhere. Is like so let's say when you think about like AI, data scientist, data science, or like big data or software engineering, all of them require software engineering knowledge. So start with maybe developing a full stack application, and you may have seen some in college or outside college, is like end to end. So something like, hey, build a website, build a backend, build a database. Now, when you do all these things, um, you kind of used like maybe not in first project, but first, second, third, somewhere you will start realizing where your interest is, because some people is like, hey, I don't like building like front end. It require like so much understanding, like, hey, I'm not good with colors or I'm not good with fonts. um, it does not interest me, but I can write lot of back end code, then maybe back end is good. Or someone may be like, hey, when I'm building a database, it interests me a lot, like how to store a data. I want to look like, I want to look into business side of that. Like if you look into any website, and if it interests you a lot, like, hey, um, how they, what their business is, how it works, how their data flow, or what kind of analytics they do, then it's like, hey, you may try to explore data or ML side of that. And mostly I'll say like start with software engineering, and then you can like get to know over a period of time. Sometime even when you join an organization and you get to work, then you will realize. But like just don't put lot of focus on just understanding what you want to, which area you want to pick. Just develop some projects, 1 2 3 5, whatever you can do. And during that phase you realize, maybe you may not know like what one thing you want to do, but you will realize these 10 things you don't want to do. Yeah.
Thank you so much, sir.
Your voice is breaking if you're talking. um, sure, yeah. Um, I think, do we have any other questions, or is it a good time to end the meeting?
Thank you so much, sir, for showering us with your guidance today.
Yeah, welcome. Yeah. Sure. I think feel free, you guys, to reach out to me over LinkedIn. Like, feel free to message if you need anything. Yeah, I'll like mostly I don't look every day, but if I get time to look into that, maybe I'll try to reply within like couple of days or a month or a week. Sorry. Yeah. Yeah. Thanks, guys. Yeah. Um, yeah. Should we end the meeting, or? Sure, I'll drop off. Thanks, guys. Thanks, everyone. Yeah. Bye bye.
Now this session is end. Thank you for everyone joining the session.